spherical tank takes more time to fill that one. So once spherical tank is moving to the steady state value, at the middle also interacting. That time only from water it is coming to this side. So we cannot stable the level of conical tank. That is another non-linear. One is a variable area, another one is the interacting between the two tanks. Considering these two non-linear, we have to design the PID controller. So that non-linear system means PID control single grain cannot be used. That is as per the law we know that. Then we need to go for the multi-model. So but we have used the single PID controller also. Then we have checked the performance of not achieving the actual performance. So we went for the multi-model system. So multi-model means just we have to divide the height of the tank into 3 regions. Okay. So same spherical tank and conical tank. One is a 50 centimeter, another is a 60 centimeter. So 0 to 15 1 centimeter, 15 to 30, 30 to 50. Like that we have to divide in the conical tank. As well as the spherical also 60 means 0 to 20, 20 to 40, 40. So exactly 0 to 20 means bottom side, 20 to 40 is the middle, 40 to 60. So 3 different. So how to divide that one? Do you know any technique to divide? Simply I cannot divide 0 to 20, 20 to 40. So I know that I will. So another technique is available, that is a gap metric method. Okay. So gap metric method is so that is here gap metric method. Okay. So using the gap metric means that is we are identifying one model. Okay. For I am dividing first 3 regions. Now instead of 3 I can divide into 9 regions. So using that 9 region, if you are using 9 controllers you have to use. That also takes more time. So I have to minimize to 3 or 4 regions. So minimum number of linear regions I need. So how to find out means we have to find out the gap between each region. So first region and second region, I divided into 9 regions. So now first region and second region, I am giving the same input to that. So if you are getting same output, that models are almost same. Is it? So we can combine that one. So second and third. If it is deviating from the actual value, then we can take 1 and 3. Then 3 and 4 is same means we can take 3 or 4. 4 and 5. Like that we are finding the distance between the each model. Okay. So if distance also you have to make some what is that? So point, that is 0.5. The distance should be 0.5. Distance should be 0.7. Like that your tuning parameter you have to select. Then based on that you have to select. So it is very near to that is 0 to 1 only. So it is very near to 0. Very near to 1 means it is very close to each other. 0 means it is very apart from each other. So that model you have to select. Very close to 1 means you can discard any one model. Like that we have to divide. So we have divided, first we have selected almost 10 regions. Then we have using the gap metric formula we divided into almost 4 regions. 4 or 3. Okay. So here almost 4 regions. We have divided into 4 regions. So initially I find out almost 10, T10. Okay, transfer function model 10. 10 region I got divided. So using gap metric formula I have taken, so that I have taken a minimum point is 0.12. So it's very close or not, like that I got checked. The region is 0.5. Okay, like that approximately I have to select. I cannot take 0.7 also, I cannot say 0.05 also. Approximately I have to select that minimum number of region as well as optimized effort also we need. If you are selecting only one model, there is no use. That also I have to consider. So then I have selected the 4 regions. So after that 4 region, for example I given a 3 region. If now I am giving the input to all 4 models, okay, all 4 models are giving output. Okay, so now which output I have to take? All 4 models, if I am adding, the output will be very high, not in the limit of my system. So again I have added one weight scheduler. Okay. So that model, using that model, I have designed the controller actually. That's the model validation I am telling. So what are the model? How to select the model means we have to set the output, which one is very close to the actual output by using the weight scheduler. So the weight scheduler means that is giving the output based on the, that is giving the weightage for the each model. Okay, weightage. So now 1 to 4 model is there. I am giving set point or open flow near to the third model. So near to third model means third model is almost height, that is 40 centimeter. Example 40 centimeter third model. 60 means fourth model. Assume that. So I am giving the input like a third model input. So now you are getting almost 30 centimeter. So now we have to check weight for each one. So 30 centimeter your current output. So now you have to check which model is giving 30 centimeter, third one. So third one you can give as a weight as a 1. First model is giving as a 10. Then giving as a weight is 0 or 0.1. The total weightage will be 1. So the 0.1 or 0.01. So next 0.5 or 0.05. Now next, which one is very close to the actual output, that is a higher weight. So like that we have to schedule one weight scheduler. Okay. That weight scheduler also, that is a fuzzy based weight scheduler is there. The triangular method or Gaussian method is available. But using AI also we can schedule. Using reinforcement learning or one fuzzy logic or one neural network, we can identify which model is close to the current output. Then that model we have to give the higher weightage. So all the weightage will be, if you see from the weight scheduler W1, W2, W3, how many models are there. So from the, here I have added the controller, just I am telling the model validation, which model is it. So each model output is coming, you have to multiply. So then after that you have to use that sum all the values, that overall value is the actual output. Okay. So the same, the multi-model concept I have designed for the controller, multi-model controller. So 4 region I have selected, so 4 controllers I have designed, 4 PID controllers I have designed. So the PID controller values was determined by reinforcement learning. PID controller values determined by the reinforcement controller. So 4 PID controllers are there. So all the PID controller, whenever set point is giving based on the current value, error is generated. Based on the error, all the controllers are giving output. Now the question is which output we have to give for. Controller output is the process input. So which controller output we have to give as a process input, we have to decide. That we can decide using the weight scheduler. So based on the current output, current 30 centimeter, which model is close to that one, which controller is giving the correct output, we have to select. So from the W1, W2, we are giving the 0.1, 0.2, 0.3 like that. So it is multiplied by the controller output, then total output we are adding, that is the input of the process. So how much flow, here the input is the flow, the tank system input is the flow, output is the height of the water. So how much the input has to, we have to give to that one, okay. So then total this actuating, so how much input means how much the flow we have to give, and based on the flow the actuator valve has to open or close, 50% open, 60% open, like that we have to open. So it is going to the system, flow how much actual real-time system it is going, and we are getting the output, okay. So here 2 things we can add as a AI. The first one is a weight scheduler. Weight scheduler also we can design using the AI. So any neural network or fuzzy logic controller or reinforcement learning or any AI can be used as a weight scheduler. So it is predict the actual value and it is giving the weightage for each controller. Then all the local controller also you can use as a reinforcement controller, or you can use a PID controller. PID values will be tuned by the reinforcement control, reinforcement learning. Okay. So 3 things you can do as a research project. Same, this idea you can implement any system. Here I told about that tank system. Then in your, if you are using drone you are using. As I told, here is a minimal effort. If you are going higher altitude, you need more effort. Then that time you can use the same multi-model. That is, they are using multi-agent system now, drone also. You can use a multi-model system. Converter also, different power you are using means you can use as a multi-model. So wherever non-linear system is existing, okay, you can use as a multi-model. This is the one new idea. Then same weight scheduler only. Weight scheduler also you can use a AI for scheduling the weight to control that. Okay. The same way. So here we have designed the reinforcement learning controller for tuning the PID values first thing. Okay. So the reinforcement, this is the actual black diagram of the reinforcement controller. It is having the agent and environment. Okay. So the agent is working based on the environment. Environment is given as a mathematical equation of the time system. So it is giving actual input and it is giving then what is the output it is sensing. From the sensor it is sensing. Then it is giving the based on the action. Then the reinforcement learning algorithm based on the action